snowball, that energy is greater than the energy that's holding the snowball together. Because hardly any energy is holding the snowball together. It's just loosely packed snow. So when you do it against the wall, you see the snowball completely disappear in a mini snowball explosion, if you will. So this works for any comparison of projectile speed and what we call the binding energy of the object itself. This is why the intercontinental ballistic missiles never carried conventional warheads, because their speed coming out of space, because they leave the atmosphere, go from one continent to the other, then they fall out of the sky. That speed gives them more kinetic energy than any conventional warhead would have had.
Whoa.
But then we figured out how to make small nuclear warheads. The nukes. Now you're talking energy. The kinetic energy of the ICBM is not higher than the nuclear warhead that we now put in. That's why all ICBMs are nukes.
Wow.
The V-2 rocket basically didn't need an explosive warhead in its tip. It came out of the sky going 5 miles per second. There was none of this. That implies you're hearing the thing. It's coming in supersonically.
Whoa.
You're sitting there at a cocktail table on a block, and then the block is gone, is obliterated in the next instant. You didn't even know. You didn't even know to look up.
Wow.
So that's and they added an explosive anyway, but they probably didn't need to.
Now, to go back to Shoemaker-Levy, that was a comet that slammed into Jupiter. Now, Jupiter's a gas giant.
Yes.
I've always been confused as to what that means.
Oh, most of its mass is in the form of gas.
Most of its mass.
Oh, yeah,
90%.
Yeah.
So when Shoemaker-Levy slammed into Jupiter and
It was
made an
going so
explosion,
fast, the gaseous atmosphere was like hitting a brick wall.
Whoa.
That's how fast it was moving.
So that's why the explosion